known for his inspiring personality. He was born in Naren in Calcutta to the Datta family on 12th January 1983. He made an everlasting impact on the world culture and religion through his groundbreaking speech. His preachings invoked the virtue of humanity and sympathy to the people generation wise. So I would like to dedicate this session in the name of Swami Vivekananda. Now I would like to introduce the resource person of today's session. We are privileged to have Professor H. Ramananda Singh with us today. Professor H. Ramananda Singh is a professor in the Department of Business Administration, Assam University. He has done MSc in Maths from Lucknow University and MBA from Banaras Hindu University and PGDCA and PhD. He has 25 years of teaching experience. His area of interest are general management, marketing management, and research methods. He was director of UGC HRT, Manipur University for 5 years. 7 research scholars were awarded PhD degree under his supervision. He has published 4 books, 32 publications in Refer Journal, 9 articles and chapters in published books, 2 articles published in proceedings and seminars, 4 papers presented in regional seminar, 11 papers presented in national seminar, and 7 papers presented in international seminar. We welcome you, sir, to today's session. Over to you, sir.
Sir, I welcome you again, and the session is yours, sir.
Thank you very much. Thank you very much. So we'll be starting while remembering Vivekananda, and I do believe that this session will make interesting to all of us. My dear friend, I don't know much. Whatever little thing I know, I would like to share with you. And in the process, if you want to ask any question, you just write down. I'll be watching in the chat box. You just write down the question, and I will be observing from time to time, and then I will try to answer your query. So let us begin while remembering or recalling the Vivekananda. At the beginning, as I have said, I don't know much of the statistics, and whatever little thing I know is relevant to my teaching of marketing management or teaching of my general management. So as a research scholar, you're not supposed to know everything. You can just catch hold of something, some technique which are relevant to your area. So in the social science area, you may be in commerce, you may be in economics, try to know some of the important techniques which are relevant to your field. And we are not supposed to know each and everything about the statistics. So I don't know much. I have a little knowledge about the statistics which are applicable in the field of management and social science that I would like to share. Today I'll be taking up hypothesis testing, parametric and non-parametric. So I will show you the slide. Jyoti, is it visible? Slide.
Visible, sir. Go to the first place, sir, please.
So in this 2 weeks workshop on research methodology and applied econometric social sciences, I'll be taking up parametric and non-parametric methods in hypothesis testing. And after 1 hour, before next session, in this same section, our beloved brother, Dr. Demalo Ghosh, will be dealing with the ANOVA part. So I'll be starting with the parametric and non-parametric methods.
Sir, can you make the slideshow, sir? It would be better. Yeah, thank you, sir.
Okay. So to begin with, one question is, what is hypothesis testing? What is test of significance? And what are parametric and non-parametric tests? Often in hypothesis testing, people will ask you what is hypothesis testing and what is test of significance and what are parametric and non-parametric tests. See, research is a process. These are the steps given by Kothari. And why research is a process? A step-by-step way of doing the things. It is a step-by-step way of doing the things because to minimize the error. If you do something step-by-step, then you will minimize the error. And by doing step-by-step, we're trying to make research a scientific approach. So somewhere there is a formulation of hypothesis. So hypothesis is there in step 3. And if you have a hypothesis, then it has to be tested in the step 6 data analysis. So the one question may be, is it a hypothesis needed for all type of research? And if it's needed, then why it is needed? If it's not needed, then why it is not needed? We need to understand that. So in the step 3, there is a formulation of a hypothesis. One question is whether we need hypothesis in all the type of research or not. So then what is hypothesis? See, with the available incomplete information, we make some assumptions. That is hypothesis. And a hypothesis is a conjectural statement of the relationship between two or more variables. For example, while traveling from one place to another place, you find that the more the younger people, the people wear colorful dresses, then you can make the assumption, the more the young people wear colorful dresses. So whatever that comes in your way through observation, you can make an assumption, and that assumption is on the basis of incomplete information, and that has to be tested. So hypothesis means a mere assumption or some supposition to be proved or disapproved. The basis, how will you formulate the hypothesis? See, normally you frame the hypothesis with your prior knowledge, by review of literature or by theory. Normally, hypothesis formulated from the observations of the researcher. As I just mentioned that while traveling a long distance by scooter, I found that the more the younger people wear colorful dresses. So my assumption is that the more the younger people wear colorful dresses. It may be false, but it is my assumption, and we have to test it. So for what it comes in the researcher's way, the researcher form opinion, and there is the hypothesis. So normally with the review from the review literature or from the theory, you can formulate the hypothesis. For example, large farms with rich resources are farms that are more multi-product. The large farm with rich resources are farms that are more multi-product. Employees of different banks have different level of stress. So these are the assumptions. The male and female bank employees have different level of stress. But remember one thing, when you make the hypothesis should be written in the present tense only. The theory says that whenever you make any assumption, hypothesis, it should be written in present tense only. Now, is hypothesis necessary? Now, if your research is exploratory research, there is no need for hypothesis. And the whole says, inquiry order on firing, misappropriation of fund, etc. come under this category where you will not be having any hypothesis. Number one, if your research is exploratory research, there is no need for hypothesis. And then in conducting studies to find out facts, no hypothesis needed to be framed. Generally, the studies initiated by the government or the autonomous organization would be of this type. Inquiry ordered on firing, there is no need for hypothesis. Inquiry order for misappropriation of fund by the government or by the minister, there is no need for hypothesis. Now you look at this. This is from marketing research by Harper W. Boyd. Exploratory research leads to formulation of hypothesis. Then you conduct conclusive research. Then finally you take a decision. So if your research is exploratory research in nature, then there is no need for hypothesis. But if it is conclusive research, then it should be preceded by the hypothesis. Forms of hypothesis. There are two forms of hypothesis: null form and alternative form. And we do not put by S0 and S1. Now, recently we came across different types of hypotheses. Earlier, in statistics, we find only two types of hypotheses: null and alternative. But the recent trend is that many people started making different types of hypotheses. Now for every objective, you can have hypothesis. Now, for example, your title of the study is a study on anxiety of teachers of Assam. For example, we want to study the anxiety level of teachers of Assam. Then objective of the study will be to compare the mean scores of anxiety of male and female teachers of Assam. Suppose one of your objective may be to compare the mean scores of anxiety level of male and female teachers of Assam. Then if you frame like this as a hypothesis, then it will become research hypothesis. There is no significant relationship between the gender and anxiety of teachers. If you make a statement like this, there is no significant relationship between the gender and anxiety of hypothesis, then it is a research hypothesis, simply research hypothesis. But statistical hypothesis is something else. There is no significant difference in the mean score of anxiety of male and female teachers. Then if you make a statement like this, then it's called statistical hypothesis. Now earlier, we have two types of hypotheses. Now we have two forms of hypotheses, null and alternative. Now nowadays, that alternative hypothesis, people make it as a hypothesis for a study and name them as directional hypothesis. And this can be done only when you have firm belief that this is going to happen. You have the data as an evidence to prove that this is going to happen. Then only then the alternative hypothesis can be used as directional hypothesis. And it is the earlier form, that is alternative form of hypothesis. There is significant difference in the mean score of anxiety of male and female teachers. Now, what is operational hypothesis? If you see, for measuring the anxiety, tools are there. If the tools are developed by you, then it has to be tested for its validity and reliability. But you are using a standard tool which were being developed by somebody else, and that tool you are using to measure the anxiety, then it is called operational hypothesis. Then you have to make the statement like this: there is no significant difference in the mean score of anxiety of male and female teachers when anxiety is assessed with a help of a scale developed by P.K. Gupta or anybody who have. If you borrow the tools developed by somebody else, then you have to mention the name, and that hypothesis will become the operational hypothesis. So these are different types of hypotheses coming up in the recent trend. Regarding the test of significance, meaning of test of significance, I would like to say here regarding the test of significance. Suppose in our university, suppose in Assam University, there are 200 males, and then there are 200 males, and then 300 female teachers. There are 200 males and female teachers, and it was found that anxiety level of male is 90, and the anxiety level of female is 85. We have covered all the teachers of all the male teachers of Assam University. We have covered all the female teachers of Assam University, and then it was found that the level of anxiety of male is 90, and the level of anxiety of female is 85. Now the difference is 5. Difference is 5. Now the difference is 5. So for this, there is no need. If you have covered all the, if you have studied the census study, there is no need for hypothesis testing. But if you have taken a sample, says from 100, you found that the level of anxiety is 90, and here a sample is suppose say 60 sample, and you find the anxiety level is 85, and this difference 5. Whether this difference 5 is significant or not, you have to test. Now, whether this significant, the difference 5 is by chance or in reality there is a difference. If you had studied the entire population, then the 90 minus 85, 5 was reality. There is a real difference of 5. And there is no need for testing the hypothesis. But if you have made a sample study, and a sample finding is that from the 100 sample, from the 100 male teachers, you find 90 level, 90 is the level of anxiety. From the 60 female teachers, you find 85 level of anxiety. Now you have made a sample study. Now this difference of 5, whether it is because of the sampling fluctuation, or whether this is by chance, or in reality, that is, or in reality, is there, in reality, this is the true difference or not. If you want to check it, then you have to test the hypothesis. So if you made a census study, there is no need for testing the hypothesis. Meaning of test of significance means what? Whether this difference is significant or not. If it is significant, then the difference is this difference is by chance plus true difference. But if it is insignificant, if this 5 is significant, then these 5 differences contributed by chance as well as true difference. But if it is insignificant, insignificant. If it is insignificant, then this is by chance only, by chance only. So what happens is that we test the significant difference if the data are collected from the samples. But if the data are collected from the population, there is no need for testing the significance. Simply you can come to a conclusion directly from here that males' anxiety are more than female. But if you had made the sample study, then before drawing the conclusion that male are having more anxiety than the female, you have to go for testing the significance of difference. Here lies the importance of testing of the hypothesis. Now, one thing you read through this note, you read this one. All the procedure used in testing the significance of difference are applicable only when probability is sampling. When it is probability sampling. When probability sampling, when probability samplings are used, probability samplings are used. If you use the non-probability sampling, you can't go for testing the hypothesis. Testing of significance or test of hypothesis can be done only when your samples are, when your data are collected from the sample, that sample is probably selected from probability sampling. There are two types of sampling, probability and non-probability sampling. And if you follow the non-probability sampling, you can't go for testing the hypothesis. Hypothesis testing or test of significance is open to only those that are collected from probability sampling. Now, general hypothesis testing procedure. General testing hypothesis. So, first step, you have to state the null and alternative hypothesis. The form of hypothesis, null and alternative. The second one was you have to select the level, desired level of significance alpha. So for knowing the hypothesis testing, you should know some terminology. One is what is null hypothesis, what is alternative hypothesis, what is alpha, the level of significance. Then you should know under what condition a particular test is applied. Different tools require different conditions. Then after that, you have to determine the decision rule or zone of rejection and zone of acceptance zone. You have to make it. After that, you have to make a calculation. Then you have to draw the conclusion. Finally, you have to draw the conclusion about these are the main 5 steps. For following these 5 steps, you have to know certain terminology. What is type 1 error, type 2 error? What is alpha? What is degree of freedom? What is zone of acceptance, zone of rejection? And what is parametric test and what is non-parametric test? You should know this terminology. Only then you are ready for testing the hypothesis. Let me repeat once again. You have to understand what is type 1 error, type 2 error, what is alpha, what is beta, what is degree of freedom, and then what are the conditions for application of t-test, what are the conditions for applying chi-square, what are the conditions for applying regression, correlation. So for every technique, there is a condition under which you can apply it. Only then you are ready for testing the hypothesis. So I will be dealing with the parametric statistics. So there are 2 types of statistics. One is parametric and another is non-parametric. Parametric statistics depend on the population parameter, such as mean, median, variance, population size. Constantly you will be calculating mean, median from the population data are needed in the calculation of parametric statistics. But in the case of non-parametric statistics, do not depend on population parameters. When we talk about population parameter, means mean, median, mode that you calculated from the population are not needed in the calculation of non-parametric statistics. So parametric statistics are Z-test, T-test, and F-test. Nowadays, with the coming of SPSS, Z-test, instead of Z-test, we calculate in all the situations where Z-test is feasible, we're using a T-test. Earlier, T-test is for small sample, Z-test was for large sample. We used to calculate manually. Now, in SPSS, there is no Z-test. So for even large sample size, T-test can be done. So Z-test you will not find in the SPSS. So Z-test, T-test, F-test are all parametric. Non-parametric, chi-square, Kolmogorov, Smirnov D-test, McNamara test, and so on are non-parametric statistics. So non-parametric statistics is also called distribution-free statistics because it doesn't depend upon the the natural distribution of data. But for parametric, it will depend upon the normal distribution. So these are all parametric statistics. I don't know all, I know few. T-test, Z-test, one-way ANOVA, two-way ANOVA, three-way ANOVA, one-way ANCOVA, two-way ANCOVA, three-way ANCOVA, trend analysis, correlation analysis, regression analysis, canonical analysis, correlation factor analysis. See, chi-square you will find under non-parametric, but it is for measuring the difference of the variance, that it comes under parametric. Chi-square you will find in two places, one in non-parametric, one under parametric. If you want to measure a significant difference of variance between two sample or three sample, then you have to go for chi-square test. So this chi-square test for significant difference in variance comes under parametric. Simply chi-square for goodness of fit, chi-square contingency, that comes under non-parametric. So we don't know all. You are also not supposed to know all. Supposed not to know all. So you just try to know those techniques which are valid for your discipline. Either you may be in commerce, economics, or sociology. So you just pick up those techniques which can be applicable to your stream. The non-parametric, these are non-parametric. Chi-square goodness of fit, chi-square contingency, Magnemer test, Kolmogorov test, then median test, man with need test, sign rank with coefficient test. These are all non-parametric. Now, normally, your parametric statistics is used when the distribution is normal, but non-parametric can be used for any distribution, either normal or non-normal you can use. But when if you want to use parametric statistics, then your distribution of data should be normal, and data should be collected on interval and ratio scale. Last time I remember one session was already done, that there are 4 types of scale: nominal scale, ordinal scale, interval scale, and ratio scale. For parametric statistics, data should be collected on interval scale or ratio scale. But for non-parametric, any scale, you collect on any scale, then you can use it. But parametric statistics are regarded as being more powerful. That's why in PhD and in publication of articles, many people are using parametric statistics only because non-parametric statistics is considered to be less powerful. That is the reason why people try to use parametric, not the non-parametric. Non-parametric is used only when you could not apply the parametric statistics. The ultimate option is that you have to go for non-parametric, but it is less powerful. So under the non-parametric, today I'll be discussing t-test. Under the non-parametric today I'll be discussing t-test. So one sample t-test, independent sample t-test, and pair sample t-test. Now, if you want to go for, suppose if the data is not normal, don't get worried. So you go through equivalent. You wanted to do one sample t-test, but your distribution data is not normal. Don't lose your heart. Go for one simple recombination sign test. Okay, you wanted to go for independent sample t-test, but the data is not normal. Then don't lose your heart. Go for man-Whitney test. You wanted to go for pair sample t-test, but your data is not normal distribution. Go for pair sample Wilcoxon sign rank test. So today in this session, I'll be covering under the parametric t-testing and then chi-square for under non-parametric. See, you collect the data by questionnaire or by observation. Assemble the data, bring the data into order, arrange the data systematically, summarize the data into order. You will be summarizing the data with the help of mean, median, mode, measure of central tendency. See, with the help of questionnaire, you collect the data, then bring the data into order, make the categorization, male, female, high, you make the categorization, then you summarize the data with the help of measure of central tendency, mean, median, mode. After that, you select the appropriate analytical tool for examining the difference, analyzing the experimental data, or for measuring the association. This is the flow chart. We collect the data by observation or by telephonic interview or by questionnaire, whatever the case. Then bring the data into order, arrange the data systematically in order, make the categorization of data, then summarize the data with the help of mean, median, mode, which we call it measure of central tendency, descriptive statistics. With the help of descriptive statistics, summarize the data. One of the fundamental objectives of statistics is to find one single figure. When we ask you how much mark you got in master degree, you say 80%. You don't say that. In paper number 1 I got 90. In paper number 2 I got 70. In paper number 3 I got. You never said that. You said one figure, either is 80% or 60%. Why? That figure is a representative. Summarize the data into order means you have to go for measuring the central tendency to get one single figure. Summarize. So one of the fundamental objectives of statistics is to find one single figure which is representative of the unorganized data. So you have to summarize the data. Now, selecting the appropriate analytical tool will depend on some conditions. You will be selecting the analytical tool for examining the difference or analysis of experimental data or measuring of association will depend upon this condition. What is the analytical technique intended to do? What exactly are you looking for? Scales in which the data are measured. Last time one of our faculty member has done the scales: nominal scale, ordinal scale, interval scale, ratio. On which scale data are collected? And parametric or non-parametric data. Number of variables to be analyzed, dependence on independent, number of samples. Depending upon this, you'll get a technique. So these are the conditions. So there is a condition for applying every each technique. Until and unless those conditions are not being fulfilled, you can't use chi-square, you can't use the t-testing, you can't use ANOVA. First, you have to see whether the conditions are fulfilled or not. Now, t-test. In the t-testing, you'll find 3 methods: one sample t-test, independent sample t-test, and pair sample t-test, or related sample t-test. Pair sample t-tests are also sometimes called related t-test or correlated t-test. So one sample t-test, independent sample t-test. I'll show you how we use calculate manually, and I will show you how it can be done with the help of SPSS. One sample t-test. So assumptions. The data that you have collected should have a normal distribution. Homogeneity of variance means if you have 2 samples, then the variance of the first sample should be equal to the variance of the second sample. Variance is standard deviation square. Data must be either interval or ratio. Data must be either collected on interval or ratio scale, and there should not be any outlier. Extreme items should not be there. Small value or large value should not be there. So extreme items, we call it outlier. So all of the procedures used in testing the significant difference are applicable when the probability sampling are used. Again, if you want to go for testing the t-testing, then you should make sure that you have followed the probability sampling method. See, sample is the representative of the population, and sampling is the process of selecting items to be included in the sample. So how you select item? By probability method or by non-probability method? So if you use probability method of choosing the items to be included in the sample, then you can use t-testing. See, normal distribution plays a very important role that I will not go in detail. Normal distribution is distribution of continuous variable. Continuous variable. And continuous variable is required as a dependent variable in all the research. I'll come to that point. So you should know more about the normal distribution. And from normal distribution, you will come to know how standardized Z variable, the Z test was being developed. And then with the help of normal distribution, you can easily find the sample size also. This is derived from the normal distribution. So normal distribution plays a very important in research. If you want to know more about the research, first learn what is normal distribution. Now, this one, while conducting the social science, research in social science, often we mention two types of variable. Continuous variable, sometimes people call it criterion variable. So continuous variables are those variables which can be whole number as well as fraction. Achievement, anxiety can be whole number as well as fraction. And these continuous variables are, that can be actually in whole number. When we say gender, gender cannot be half male, half female, either completely male or completely female. So residential background, rural, urban, caste, general, OBC, SC, ST, number of pages in the book. We can't say that there is 200.5 pages. We always say full page number of. So here you have to talk about the whole number, discrete. Again, in the experimental research, dependent variables will be continuous variable, and independent variable are discontinuous variable. So you should know these two type of variable, continuous variable and discontinuous variable. And your normal distribution is a distribution of continuous variable. That's why before testing any technique in parametric, we go for testing of the normality. Because in day-to-day life, whatever the variable we found are continuous in nature. And that's why you have to check whether the data you collected is having normal distribution or not. And normal distribution is a distribution of continuous variable. The normal distribution or normal probability distribution happen to be the most useful theoretical distribution for continuous variable. Since we are using continuous variable, the type of distribution should also be normal. See, normal curve is like this. But if it is not normal, it can be either skewed or either it can be left skewed or right skewed, or it can be more flat or more peak or more flat. So there is a limit for acceptance. You will not get a data where mean is equal to median is equal to mode. But there is a limit or acceptable limit. If the curve is like this, then we can consider it as a normal. So you have to go for testing the normality of the curve. In all the data, it will be very much difficult to find mean equal to median, median equal to mode. In the normal curve, mean equal to median and then equal to mode. But you will not get that. But my data will be near to normal. And if there is an acceptable limit, they will show you the acceptable limit. So this is normal curve. So if it is not normal, then it can be positively skewed or negatively skewed on the left side or right side, like this. Positively skewed is on the right. There is a variation on the right side, skewed like this, the right side, and then symmetrical. This symmetrical is normal, and it can be negatively skewed on the right side. So there is a limit of accepting the normality. Or the skewedness will be there, but there is a limit. The limit we have to find out. Then kurtosis, your data may not be exactly normal. Sometimes it may be more peak or lesser peak, like this. Kurtosis tells you whether your data is having more flatness or having more peak. So normal distribution is in the middle. And here, positive kurtosis or letokurtic is more peak. And then here, this one, flat one. Negative kurtosis or platykurtic, this one. And your normal distribution is mesokurtic. So your data may not get exactly normal distribution, but there is an acceptable limit. If the kurtosis level right to what level we can consider as a normal, then I'll tell you. So why normal distribution data is important? Why? The normal distribution is the most important probability distribution in statistics because it fits many natural phenomena. For example, high blood pressure, measurement error, and IQ score follow normal distribution. And then one reason the normal distribution is important is that many psychological and educational variables are distributed approximately normally. And normality test is used to determine whether a sample data has been drawn from a normally distributed population within some tolerance. Then what is it the tolerance? Acceptable. Within some tolerance means within certain acceptable limit. A number of historical tests such as students t-test and one-way ANOVA, two ANOVA require normally distributed sample population. Histogram, you can also check whether the data is, with the pictorial method, you can check when you draw the pictorial gram, whether it is normal or not. So this one middle C is a normal distribution and A is not normal and B is not normal. A is skewed towards the right and B is negatively skewed towards the left. And normal is this one C. So you can check with the help of pictorial diagram whether your data is normal or not. And box plot, this is called box plot. So and so this one is normal. This one is right skewed. This one is left skewed. With the help of box plot, you can determine whether your data is normal or not. Then with the help of QQ plot, quartile. With the help of QQ plot also, you can determine whether your data is normal or not. So this figure indicates when your data will be normal. Now, this is the data. See, Type of school, gender, 1 male, 2 female. Type of school, 1 government, 2 private. Location, rural, urban, 1 urban, 2 rural. And this is the level of stress of the level of stress of the teachers. Gender, type, school, location, and the teacher's level of stress. Now, this level of stress, you can check it whether it is normally distributed or not. You can check this one. First, you have to check whether these data are, before applying any tools, any particular parametric, you have to check whether these data are normally distributed or not. Diva, Dr. Divjyoti, it is hang. Dr. Divjyoti,
We can see
hello.
some slides.
It is hang. It is. Shall I stop sharing and let me share once again?
Yeah, you can stop share. Yeah.
It was hang.
So you have shared the PPT directly, so SPSS might not be seen.
Okay. Now, is this visible?
Visible, sir.
Now you can check whether your data, whether it's normal or not, with the help of these 3 techniques. You can check the normality of your data collected from a sample, whether it is normal, with the help of these 3 techniques. One is Z-skewness, another is Z-kurtosis. Under the A, we call it descriptive statistics. You have to calculate Z-skewness by skewness divided by standard error of skewness. Z-kurtosis divided by standard error of kurtosis, or Kolmogorov-Smirnov test normality is there in the spaces, and a Shapiro-Wilk test or graphical method. So you can check whether your data is normally distributed or not with the help of descriptive statistics in the form of Z-skewness, Z-kurtosis, or by Kolmogorov-Smirnov test of normality or Shapiro-Wilk test normality or graphical method. But when to use it, when to use the question, you go through this one. Is it visible? Is it visible?
Visible, sir. Slide visible.
Yes,
If the sample size is less than 50, if the sample size is 50, then you can check the normality with the help of Shapiro-Wilk test, Z-skewness, Z-kurtosis. So if you follow Shapiro, then if your data will be normal, if P is greater than 0.0, you notice this one. If the sample size N is less than 50, then you will go for Shapiro-Wilk test, and it will be normal if P is greater than 0.05. But Z-skewness and kurtosis will be, the value should lie between plus minus 1.96. But regarding this, some author says that it should be 2 plus 2 minus 2. But many people follow the standard value. So there is a skewness, but tolerable limit is that it should have the value between 1.96 to minus 1.96. This is tolerable limit. But if the sample size is greater than 50, less than 300, then instead of Shapiro, you have to go for Kolmogorov-Smirnov test. And your data will be normal if the P is greater than 0.05. But if the large sample, then you can test the normality with the skewness, kurtosis, as well as histogram and box plot. So skewness, kurtosis, normally if the skewness is plus minus 2, here we say plus minus 1.96, plus minus 0.2, because some author says that the value of symmetry and kurtosis between -2 and -2 are considered acceptable. And in order to prove normal, so this was said by George and Mallory. And Brian says that argue that the data is considered to be normal if skewness between -2 plus 2 and kurtosis. So some author have a different view. So if you are following -7 plus 7, then you got And if you're following -2 +2, then you code this right there. So one sample test. Assumption for normal distribution. Normally, when we used to calculate it by when we used to make manual calculation, there is no normal. We don't test for normal distribution. Simply we calculate it. So after knowing that it is a metric data, then we simply calculate it. So t-test formula is that mean of the one sample test, mean of the sample minus mean of the population divided by standard error. So mean of the sample minus mean of the population. So we used to calculate manually. So you go through this question. Please go through this question. Then think what can be the hypothesis. A manufacturer of a certain make of electric bulb claimed that his bulb have a mean life of 25. He claimed that all my bulbs is having a lifespan of 25 months. But researchers tried to check it. So he checked 6 bulbs. One bulb is found to be 24 months. One bulb is found to be 26 months. One bulb is found to be 30-month lifespan. So this is the sample data. So can you regard the producer's claim to be valid at 5% level of significance? Can you regard the producer's claim to be valid at 5% level of significance? So your hypothesis, you first calculate the mean life of this one. You have 24, 26, 30, 20, 21. Find the average and says that null hypothesis there is no significant difference between the mean of the sample and the mean of the population. No significant difference means what? Equal. There is no significant difference means equal. The alternative will be there is significant difference. So first step is null hypothesis. There is no significant difference between the mean of the population and the mean of the sample. And there is alternative hypothesis will be there is significant difference between the mean of the population and the mean of the sample, or mu not different from 25. Not different means equal, and mu different from mu is here is the mean of the population. Different from 25, you select alpha level. Alpha level, you should know the meaning of alpha level. Alpha level separates the zone of acceptance and the zone of rejection. If the particular value is more than a particular value, then you have to reject it. And if the particular value is less than a particular given value, then you have to accept it. So alpha will give you the zone of acceptance and the zone of rejection. So you should know alpha. Alpha, we call it alpha is a level of significance. Why t-test? T-test is required because it is a metric data. Data are collected on ratio scale, and then it is a case of trying to know the difference between the significant difference between the mean of sample and the mean of population. So the t-test condition was fulfilled mainly because it is a data collected on metric scale. So t-testing, your decision rule will be if the calculated value of t is greater than your decision rule will be if the calculated value of t is greater than the table value, then we reject the hypothesis. Decision rule will be if the calculated value of t is less than the table value, then we'll be accepting the hypothesis. Now, your sample size was how much? Sample size was 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Your degree of freedom will be n-1. So 6 minus 1 will be 5. Look at the table. For degree of freedom 5 at 5%, 0.05. For two tail tests, 0.05. So table value is 2.571. Your sample size is 6. Degree of freedom will be n-1. 6 minus 1 is 5. Now your alpha at 2 tail tests is 5%. 5% is 0.5. 5% is 0.05. You look down here. This is degree of freedom. So table value is 2.571. Now, if the calculated value of t is less than 2.571, then implies the hypothesis is accepted. If the calculated value of t is greater than 2.571 table value, that implies that is not rejected. Now you calculate it. You know how to calculate standard deviation. First, you calculate the mean. Mean of the sample is 23. Then mean variable minus mean. You calculate then this one x minus x bar square. Your standard deviation formula is, what was the standard deviation formula? Your standard deviation formula is root over summation x minus x bar whole square divided by n minus 1. First, you calculate the standard deviation. Then your standard error will be standard deviation of sample by root over n. Then you calculate AC. After you calculate the AC, now next is P formula is mean of the sample minus mean of the population divided by AC. So you have to take absolute value. So 1.084. So calculated value is less than 2.571. So implies that it's not accepted. It's not accepted. So it's not accepted. So there is no significant difference between the mean of the population and the mean of the sample. So the producer's claim that his bulb have a mean life of 25 is valid. So this is for one sample. I will show you with the SPSS. But this is a one sample test. How we calculate it manually. We calculate it manually is standard error. We calculate standard error is standard deviation of sample by root over n. First, you calculate standard division of sample. Then standard division of sample is divided by root over n. Then you get SE. Once you get SE, put here mean of the sample minus mean of the population divided by SE. You get the value. Compare with the table value. If it is less, accepted. If it is greater, rejected. So accepted. What was your hypothesis? Your hypothesis was there is no significant difference between the mean of the population and the mean of the sample. Or mean of the population is 25. Not mean of the population is not different from 25. Not different means equal to 25, and it is different from 25. So you accepted the hypothesis. There is mean of the population is 25. You accepted. So this is for one sample. Don't worry. I will show you SPSS. Now for two sample, independent sample t-test. First, we have to check the normality. Then second, we have to check the homogeneity of variance. Then data must be either interval or resource scale. For two sample test, t value is mean of the sample 1 minus mean of the sample 2 divided by SE. Then SE is root over standard deviation square root over 1 by n, 1 plus 1 by n. And this standard deviation square is combined standard deviation of the two samples. So we used to calculate manually like this. So question, there are two drugs A and B, and efficacy of drug A is given in the first column, efficacy of the drug B is given in the second column. You go through it. The two types of drugs were used on 5 and 7 patients for reducing their weight. Drug A was imported, drug B is indigenous. The decrease in weight after using the drug for 6 months was given below in table. Is there any significant difference in the efficacy of the two drugs? Now, the question is there any difference in the efficacy of the two drugs? Question is there any difference in the efficacy? Then what will be your null hypothesis? There is no significant difference in the efficacy of the two drugs. Your alternative will be there is significant difference in the efficacy, or there is no significant difference in the mean score of the reduce in weight by using drug A and drug B. There is significant difference in the mean score of reduce in weight by using drug A. Simply, you can say there is no significant difference in the efficacy of the two drugs. Alternative will be there is significant. Now, alpha taken 5%. Why t-test here? Data are collected on metric scale, interval and ratio scale, and it has two samples. So we will be using the independent t-sample test. Decision rule: if the calculated value is less than table value, accept hypothesis. If the table value is greater than the calculated value, if the calculated value is less than table value, accept hypothesis. If the calculated value is greater than table value, reject the hypothesis. Reject the hypothesis. Now, table value. Since you are having two samples, your degree of freedom will be n1 plus n2 minus 2. The first drug A has a sample of 5, and then sample 2 has a size of 7. So your degree of freedom is 10. So you look at the table. If you look at the table, for 5%, you'll find that table value is 2.228.